Sketching the graph of y equals to the absolute value of x. To sketch the graph, we're going to go back to the definition of what an absolute value is and use the definition to help us to sketch this graph. So we know that the definition says that the absolute of x equals to positive x if x is greater than or equal to 0, and it equals to negative x if x is less than 0. So using this definition, if you look at the graph of y equals to the absolute of x, you will see that the graph is made up of two parts. The first one is the graph y equals to x for all non-negative x values for x greater than or equal to 0. And the next part of the graph is y equals to minus x if x is less than 0. So we have two straight lines here. One with a positive gradient, y equals to 1x. The gradient is 1. So the shape of the graph is an increasing function. So from left to right, it increases. Y equals to negative x is a straight line. That's a decreasing function since its gradient equals to negative 1. So we're going to plot these two graphs. The first one we draw is y equals to positive 1x, the straight line. But we restrict the domain, so we only draw it for positive x values. So x greater than or equal to 0, we include 0 here. And the second graph that we're going to draw is the straight line y equals to negative x for all negative x values. So I'm going to start by drawing the graph of y equals to 1x. I'm going to substitute values. I'm going to do this verbally with you, mentally with you. I am not going to draw a table because it's a straightforward graph. It's a straight line. So we start by substituting x equals to 0 because 0 is part of the domain. So when x is 0, we get that y is 0. The next value that we substitute is the number 1. So when x is 1, y will be 1. When x is 2, I get y equals to 2 because y equals to positive x. When x is 3, y is 3. When x is 4, y is 4. So immediately you see that this is a straight line graph that has a positive gradient. Let's sketch this graph. So the graph continues. I'm only going to draw a short piece of the graph. So this is the graph of y equals to positive x. And remember, we're only drawing it for the positive x values and we include 0. Now we're ready to draw the next part of our graph, which is y equals to negative x. So I'm going to substitute negative x values. So the first x value that I'm going to substitute is the number negative 1. So when I substitute negative 1, I will have y equals to minus 1 because I'm drawing the graph of y equals to negative x. So that gives me the y value is positive 1. So when x is negative 1, y is positive 1. Similarly, when x is negative 2, and I substitute it into the equation y equals to minus x, I get x equals to positive 2. I substitute x equals to negative 3 into the equation y equals to minus x, I get x equals to positive 3. And the last, positive 4. And so I'm ready to draw the graph. You can see it's a straight line graph that has a negative gradient. So we sketch this graph. Now looking at the entire graph is y equals to the absolute of x. So the blue arm is y equals to minus x, the straight line. The green arm is y equals to plus x. But the two arms together gives you the graph of y equals to the absolute of x. So let's look at some of the properties of the graph. We see the two graphs meet on the origin at 0, 0. We call this the salient point. And looking at your graph, you can see that it is a minimum salient point because that is the smallest y value that you have for your graph. If you look at your graph, you may say that the domain is any real number. So we say x is an element of real numbers. So we may substitute any real number, and that will be a point on the graph. Our range, we see that it is exclusively above the x-axis, and so we say that y is greater than or equal to 0 for all real y values. Now that we know what the absolute y equals to absolute of x looks like, we're ready to draw the next graph, which is y equals to minus the absolute of x. So again, I'm going to use my definition. So the graph that I have will be y equals to minus plus x for all x values greater than or equal to 0. And this gives me the graph of y equals to minus x. Then the second graph that I will have will be the graph y equals to minus x, which is going to be the graph of y equals to x for all x values that are negative. So once again, we're going to use the substitution method to plot this graph. The first graph that I am going to draw is the graph of y equals to minus x for all positive x values, including 0. So if we substitute 0 into y equals to minus x, we get that y equals to 0. If we substitute x equals to 1 into y equals to minus x, we get y equals to minus 1. Similarly, I'll get y equals to minus 2 if x is 2, y equals to minus 3 if x is 3, and y equals to minus 4 if x is 4. So immediately you have an idea of what the shape is. Let's quickly sketch this arm of the graph. So we are sketching the graph y equals to negative x for the restricted domain of x greater than or equal to 0. So we're ready to do the next substitution into the equation y equals to x. So we are now going to be drawing this graph here of y equals to x. So I need to substitute negative x values because my domain is restricted. So when I substitute x equals to negative 1, I get y is negative 1. X is negative 2, y is negative 2. X is negative 3, y is negative 3. Right, so we know that this is going to be the shape of the graph. Let's plot it. Right, so the two arms together give you the graph of y equals to minus the absolute of x. And it looks like an inverted V form. The salient point is where on the origin where the two graphs, you could say the common point of the two graphs. And we see that when we have y equals to negative the absolute of x, we have a maximum salient point because this is the largest y value in the range. Once again, the domain would be x is an element of real numbers. I'm writing it here on the side. The domain, you may substitute any real number and it will be a point on the graph. Looking at the range, you see that the graph lies under the x-axis, so we say y will be less than or equal to 0 for all real values of y. Now, one more thing that we notice, do you see that there's an axis of symmetry? So I'm going to show you the axis of symmetry. The axis of symmetry is actually your y-axis. So here you have your axis of symmetry, which is the y-axis. And the equation of the y-axis, we say that x equals to 0 is your axis of symmetry. And looking at, let's just take 1 point. So here I have x is 1 and y is 1. And here I have x is 1 and y is negative. Sorry, I have x is 1 and y is negative 1. So looking at the point, I have x is 1 and y is negative 1. Then if I look at the point on to the left hand side of the axis of symmetry, I have x is -1 and y is -1.